They didn't have cranes, no steel, no electricity, no computers, and yet they raised stone giants, castles, in less than a single year. Some were towering, impenetrable, and complex, standing even today after centuries of war and weather. How? What did they know that we've forgotten? Behind every wall was a system of labor, of power, of belief. This isn't just a story of medieval engineering. It's a story of human obsession, feudal ambition, and raw survival. Because in the Middle Ages, a delay didn't just mean failure. It meant death. In 1066, William the Conqueror landed in England, not just with men and horses, but with flat-packed wooden castle parts. Within days of winning the Battle of Hastings, he had a Motte Bailey fortification erected at Pevensey. It wasn't a symbol of power. It was a defensive necessity. England had not yet been secured, and speed was the difference between holding a beachhead and losing everything. This urgency was not unique to Norman invaders. Across medieval Europe, from the 10th to the 14th centuries, warfare was constant. Territorial disputes, dynastic struggles, and rival lords competing for influence turned the landscape into a chessboard of shifting threats. Castles became a response not to prestige or comfort, but to the immediate risk of siege, ambush, or rebellion. A stronghold had to rise before the enemy returned. Every day that passed without stone in place was a day of vulnerability. In regions like the Welsh marshes, border tensions meant that lords would sometimes begin construction before they even had full control of the area. Fortifications would often start as earthworks or timber structures designed to be upgraded later. These were not temporary in intent, but tactical in priority. The siege mentality shaped every decision. Gatehouses were thickened. Towers were angled for visibility. Wells were dug first, sometimes even before outer walls, because a castle without water would collapse from within faster than it could fall to catapults. Workers toiled under pressure. Delays were not a matter of budget. They were a matter of survival, and survival was fragile. The siege of Chateau Galliard in 1203 proved this. Built rapidly by Richard the Lionheart in just 2 years, it was considered one of the most advanced fortresses of its time. Yet, even its clever concentric defenses couldn't hold against a determined French siege when its supplies ran out. Castles weren't just built quickly, they were born out of panic, calculation, and necessity. Every stone laid was a statement of intent. We are not ready to fall. From the Scottish Highlands to the Crusader states in the Levant, this urgency echoed across continents. The fear of siege was more than psychological, it was structural. It dictated pace, design, and manpower. In the medieval world, hesitation was a death sentence. Castles had to rise faster than the storm of war that always loomed just over the horizon. High ground was more than a tactical advantage. It was often the first line of defense. In medieval Europe, the decision of where to place a castle was as strategic as the walls themselves. A well-chosen location could repel armies before the first stone was set. A poor choice could turn a stronghold into a liability. Norman commanders understood this. After their conquest of England in 1066, they built over 500 castles in just a few decades. One of the earliest, the Tower of London, was not just built to guard the Thames, it was a warning. Positioned at a vital river crossing and trade hub, it cemented Norman dominance over a city that was still adjusting to foreign rule. It wasn't isolated. It was embedded in the political and economic artery of the realm. Castles were often placed at crossroads, controlling not just roads, but the movement of armies, traders, and information. Carnarvon Castle in Wales, commissioned by Edward I, in 1283, stood at a strategic junction near the Menai Strait. The message was clear. This was not simply a military base, but a statement of conquest over a rebellious region. Its polygonal towers and symbolic Roman-style architecture were meant to intimidate, but its location did most of the work. Welsh resistance had to move through Carnarvon or around it. Some locations were chosen to control access to resources. The Craigday Chevaliers in modern-day Syria, held by the Knights Hospitaller from the 12th to the 13th century, dominated a valley, linking Horns to the coast. It gave Crusader forces control over a major inland route and a buffer zone against Muslim counterattacks. Its location allowed fewer defenders to hold back much larger forces using terrain to do the heavy lifting. Natural barriers were also key. The Château de Chinon in France sits on a rocky outcrop above the Vienne River. First fortified in the 10th century, its elevation gave defenders a clear view of the valley below and made direct assaults costly. In Scotland, Stirling Castle guarded the narrowest crossing of the River Forth, acting as the gateway to the Highlands. Whoever held Stirling held Scotland's heartland. Castles weren't built where it was convenient. They were placed where they could control, surveil, and dominate. The terrain became part of the architecture. Rivers became moats. Hills became towers. Roads became traps. Every castle site was chosen with intent. Geography was not a backdrop, was a weapon. And medieval rulers learned quickly that in a time of endless war, the right patch of land could hold more power than any army. Castle walls didn't rise by ingenuity alone. They rose on the backs of thousands of peasants, conscripts, craftsmen, prisoners, and paid laborers each, playing a role in a construction system that blended hierarchy with necessity. The speed of castle building, often measured in months rather than years, depended on the sheer volume of human effort. And in the medieval world, labor was not always voluntary. In 13th century England, under the reign of Edward I, construction of castles in Wales, such as Carnarvon, Harlech, and Con required thousands of workers. At Carnarvon alone, records from 1301 reveal over 3,500 men employed in a single year. Most were local laborers, pressed into service through feudal obligation. Under this system, peasants owed their lords a set amount of labor per year. If called upon, refusal was not an option, it was treasonous neglect of duty. These workers endured back-breaking routines. Quarrymen hacked limestone and sandstone from nearby outcrops. Carpenters raised wooden hoists and scaffolds. Blacksmiths forged the iron tools that dulled and broke by the hour. Others hauled stone in endless cycles, often unpaid, beyond shelter and food. The work was dangerous. Falling from scaffolds, crushed limbs, infection injury meant poverty. There was no compensation, there was no relief. Alongside them were skilled craftsmen, stonecutters, masons, and engineers, sometimes brought from distant regions. Many were paid and even protected under royal writs, like Master James of St. George, the Savoyard architect responsible for Edward's castles in Wales. His role was part engineer, part project manager, overseeing supply chains, and labor coordination that stretched across counties. Yet even his work depended on an army of nameless men who laid the stone, day after day. In some regions, prisoners were used as a labor source. Under the Capetian kings in France, those convicted of lesser crimes could sometimes have sentences reduced through forced labor on royal fortifications. Elsewhere, coinage lured the poor with promises of day wages. In reality, wages were low, rations poor, and conditions harsh, but for many, it was still more secure than seasonal agriculture. Religion, too, played a role. In Crusader states, labor was sometimes framed as a spiritual duty. Building fortifications in the Holy Land could be presented as an act of faith, an extension of military pilgrimage. In Europe, monasteries occasionally lent labor or supplies, viewing castle construction as protection for Christian lands. What kept these projects moving wasn't inspiration. It was the medieval system of survival and control. Lords needed fortifications fast. The laborers couldn't refuse. And the state, whether king, duke, or bishop, offered little sympathy. Castles became monuments, not only to military power, but to social order. Every tower stood because thousands of ordinary people had no choice but to make it stand. Their names were rarely recorded, but without them, the stone would never have risen. At first glance, medieval construction seems primitive: no engines, no steel frames, no electricity. But the builders of the Middle Ages developed a toolkit that pushed the limits of pre-industrial engineering. They built stone giants using logic, geometry, and a handful of tools that turned raw muscle into mechanical force. One of the most effective devices on medieval construction sites was the treadwheel crane, first documented in Roman times but reintroduced in Europe around the 12th century. It functioned like a massive, human-powered hamster wheel. A laborer walking inside the wheel would rotate it, pulling up loads of stone or timber attached to a rope and axle. These cranes were capable of lifting several tons, and they could be dismantled, moved, and reused across different sections of the castle. At Windsor Castle, accounts from the reign of Edward III described the use of multiple treadwheel cranes during renovations in the 14th century. They replaced sheer manpower with mechanical advantage, increasing efficiency without advanced technology. Wooden scaffolding, though seemingly basic, was carefully planned. Platforms were tied into the rising stone walls with wooden pegs or inserted beams, called putlogs. These beams were slotted into holes left intentionally in the masonry, some of which can still be seen today. The scaffolding rose in stages alongside the structure, allowing masons to work safely at height while providing walkways for transporting materials. Mortar was another critical component. Far from simply slapping stones together, medieval builders used lime mortar made by burning limestone to produce quicklime, then mixing it with water and sand. The chemical reaction produced a binding agent that, over time, grew stronger as it absorbed carbon dioxide from the air. In many cases, medieval mortar has outlasted more modern cement-based mixers. Builders adjusted the recipe depending on local conditions. At Dover Castle in England, a clay-heavy mix was used to improve bonding in damp conditions, while in the arid Crusader castles of the Levant, finer sand created a smoother, faster-setting compound. Surveying and measurement techniques were more sophisticated than they appeared. Builders used sighting rods, plumb bobs, and square frames to maintain alignment. The mason's square ensured right angles. A tool called the groma, borrowed from Roman engineering, helped establish straight lines and right-angled corners. The builders of Chateau Galliard, commissioned by Richard the Lionheart in 1196, laid out its concentric design with impressive symmetry using these basic tools. Without machines, the process relied on planning, repetition, and delegation. Materials had to arrive in sequence. Crews had to coordinate. Mistakes couldn't be patched with modern adhesives or machinery, they had to be rebuilt. Yet castles like Carcassonne in France or the Crac des Chevaliers in Syria still stand today. Their survival is not just a testament to durability, but to the skill and precision of builders who worked with little more than wood, rope, stone, and sweat. Medieval castles may appear unique, but behind many of their imposing facades was a repeatable system. Planning wasn't a luxury, it was a matter of survival. When time was short and threats were imminent, improvisation gave way to standardization. By the 13th century, castle construction had moved beyond ad hoc fortifications. Designs were increasingly deliberate, drawn from established models that could be replicated across regions. Royal engineers, particularly in England and France, followed geometric plans with a level of consistency that allowed for rapid construction. Under pressure, square keeps, concentric walls, rounded towers each had a defined function, and each had been used before. Templates, often geometric in nature, guided the layout of walls, towers, and courtyards, helping masons execute plans without having to reinvent the process for each site. Under King Edward I of England, this approach reached new levels of precision. His military campaign in Wales, beginning in the late 1270s, produced a series of castles designed by Master James of St. George, a Savoyard architect and engineer. James had worked on fortifications in the Alps before being brought into royal service. The castles he oversaw Bow, Maris Conway, Carnarvon, and Harlech shared structural logic. Fortified gatehouses, symmetrical curtain walls, and round towers optimized for defense. These were not prototypes. They were products of refined engineering, shaped by prior models and adapted for specific terrain. Blueprints in the modern sense didn't exist, but scaled drawings and layout sketches on parchment, wood, or even smoothed earth were common. Builders used geometry not just for beauty, but for functionality. Octagonal or circular towers resisted battering better than square ones. Gatehouses were placed in vulnerable points and doubled as strongholds. The balance of symmetry and utility helped speed up decision-making on site. Materials were also planned in advance. Stone was quarried to size, sometimes miles away, then transported along predetermined routes. In the construction of Chateau Galliard in Normandy, begun by Richard the Lionheart in 1196, limestone blocks were cut and shaped at the quarry before being brought to the site. This reduced on-site labor and ensured uniformity. Standardization meant more than just speed. It reduced errors. It allowed supervisors to move between sites with minimal retraining. It created a kind of architectural language that could be read and understood by craftsmen across regions and generations. In wartime, every day counted. Planning wasn't abstract. It was a weapon. The ability to reproduce fortifications quickly and reliably gave rulers the edge. Castles weren't just built, they were deployed. A medieval castle was more than a structure, it was a machine of war built from thousands of individual components, each sourced, transported, and assembled through a logistics network that stretched across the countryside. Materials didn't arrive magically at the construction site. They came through systems slow, fragile, and labor-intensive that required coordination as complex as the building itself. Stone was the foundation. At sites like Dover Castle, Kentish ragstone was hauled from quarries several miles away. The process began with teams of quarrymen who split the rock using iron wedges and wooden hammers. Each block had to be shaped by hand, sized to fit, and then loaded onto carts. One wagon might carry only a few stones. The journey could take days. Roads were primitive, often impassable in winter, and oxenot horses pulled the loads. Oxen moved slower, but they could endure the weight and survive the terrain. Forests provided more than fuel. Timber was essential. Scaffolding, hoists, floors, roofing beams, and siege-resistant gates all required massive amounts of wood. Oak was preferred for strength, and in areas like Wales, entire hillsides were stripped bare to supply Edward I's castle program. Royal writs from 1283 ordered the felling of forests around Conwy and Beaumaris, sometimes against local resistance. Timber was cut to spec on site or in nearby yards, shaped by teams of carpenters who worked in shifts alongside masons. Waterways became arteries. Rivers and coastlines allowed for faster movement of heavy materials. At Carnarvon Castle, barges delivered stone and supplies directly to the site via the Scient River. Maritime transport was critical in remote regions, especially when land routes were unreliable or politically dangerous. Ports, bridges, and docks became part of the infrastructure, not just for defense, but for delivery. Iron was less visible, but just as critical. Nails, hinges, portcullis rails, and tools came from smelting workshops. Bellows and forges ran day and night near Castle. Sites. At Harlech Castle, records mention regular shipments of iron from Chester, hundreds of kilometers away, coordinated through royal agents. Food and shelter were part of the supply chain too. Workers couldn't build if they starved. Grain, salted meat, ale, and dried peas were transported with the same urgency as stone. Temporary camps or wooden barracks were built near construction sites, creating mobile communities that functioned for months or years. Following the path of a single stone from quarry to battlement reveals the scale. It might take days to extract, more to shape, longer to transport, and still more to raise into place. One mistake could halt progress. One broken axle could delay a wall. Nothing was automated. Everything relied on timing, weather, and sheer physical effort. Castles were monuments not only to strength, but to logistics. Behind every wall stood forests cleared, rivers crossed, and thousands of hours spent moving the immovable, one stone at a time. Castle construction wasn't a single project, it was a sequence of defensive priorities. Builders didn't wait for everything to be complete. The first structures to rise were the ones that could defend themselves, even while the rest of the work was still underway. The initial focus was often the curtain wall high, thick perimeter that created a basic, enclosed space. This wall didn't need to surround the full future footprint of the castle. Instead, it secured a core zone where laborers, tools, and supplies could operate safely. At Harlech Castle in Wales, begun in 1283 under Edward I, records showed that the outer curtain and gatehouse foundations were laid before internal buildings had even been designed. These outer walls became an immediate defense line, and everything else could be built within their protection. Gatehouses were next. More than just doors, these were mini-fortressized to funnel attackers into narrow kill zones, equipped with portcullises, murder holes, and arrow slits. The gatehouse at Carfleet Castle in South Wales, constructed in the late 13th century, was so heavily fortified that it functioned as a stronghold on its own. Builders often finished gatehouses early because they were critical for controlling access, especially during construction when movement in and out had to be tightly managed. Towers followed, often built directly into curtain walls. Round towers were preferred over square ones, as they deflected siege weapons and eliminated weak corners. At Château de Cousy in France, begun in the 1220s, the towers were built quickly and symmetrically to strengthen the curtain and provide elevated positions for lookouts and archers. These towers often doubled as housing and storage multi-use by necessity. Defensive ditches, sometimes later turned into moats, were also among the first elements dug. Even unfinished, they slowed enemy approach and made siege engines harder to maneuver. In rocky regions, where digging was slow, builders might leave cliff faces or natural escarpments as part of the defense. At Montségur, a Cathar fortress in southern France, the sheer mountain slope functioned as an early barrier long before full walls were complete. Interior buildings, halls, chapels, kitchens, and storerooms came later. In the early phases, wooden structures or tents might serve temporary purposes. Stone buildings required time, resources, and security. No lord would prioritize a chapel while the outer walls were still open to attack. The cleverness of medieval strategy was in this sequencing. Builders knew the enemy might come long before the castle was finished. Every phase had to leave the site more defensible than before. Even a half-built castle could become a fortress if the right parts were ready. Speed didn't mean rushing blindly. It meant knowing what mattered most, what would hold under fire, and making sure it was built first. A castle didn't have to be complete to defend. It just had to be ready enough to buy time. In medieval Europe, construction wasn't always driven by ambition, was often driven by fear. The pressure to build fast came not from architectural goals, but from looming threats just beyond the horizon. In the late 12th century, King Richard the Lionheart ordered the construction of Château Galliard above the River Seine in Normandy. He knew what was coming. The French crown, under Philip II, was preparing to reclaim the territory. Richard didn't wait for Parliament or finances to align. He acted immediately. In a record-breaking 2 years, between 1196 and 1198, the fortress rose with multiple walls, a keep, and advanced defensive features for the time. The motivation wasn't pride. It was the fear of losing a key stronghold on the frontier of Plantagenet territory. This urgency wasn't isolated. During the conquest of Wales, under Edward I, English engineers constructed Harlech and Conwy castles with extraordinary speed. In Harlech, labourers worked through winter storms in 1283 and 1284. Royal orders were explicit. Progress couldn't stop, even as weather and terrain made it nearly impossible. The reason was clear. Welsh uprisings were not a distant risk. They were already happening. Each castle served not only as a defensive stronghold, but as a symbol of permanent English presence in a rebellious region. Stalling meant giving the enemy time to regroup. Fear also shaped construction during the Crusades. When Crusaders captured Jerusalem in 1099, their first task wasn't to celebrate it, was to fortify. Within months, repairs to ancient walls and the addition of towers were underway. Castles like Crac des Chevaliers weren't decorative, they were lifelines. Isolated in hostile territory, the Crusader states could not survive without constant vigilance. Any delay in strengthening fortifications risked total collapse under counterattack. Even the laborers felt the pressure. In many cases, they worked under the threat of invasion or retaliation. At Carnarvon, documents show that Welsh workers were conscripted alongside English labourers. Many had lost homes to the English campaign, but they laboured on English castles nonetheless, because Refusal meant punishment, or worse. The looming threat of war blurred lines of allegiance. Building fast was less about loyalty and more about avoiding destruction. Political instability accelerated the pace. Feudal lords with weak claims or recent victories knew that an unfinished fortress left them vulnerable. A wall half built could not hold off rivals. Speed became survival, not just from foreign armies, but from internal revolts, succession disputes, or broken alliances. Fear wasn't a background emotion. It was the driving force behind the scaffolds, the mortar, and the round-the-clock labor. Castles weren't built because peace was assured. They were built because peace had already failed. Speed saved some castles, but doomed others. When time pressures outweighed planning, construction shortcuts left vulnerabilities that no amount of stone could fix. In the early 12th century, King Stephen of England rushed to assert control during a brutal civil conflict, later known as the Anarchy. Dozens of castles were erected across the country, many without royal sanction, in a chaotic arms race between rival factions. These adulterine castles, unauthorized and hastily constructed, became symbols of political instability. Largely built from timber and earth, they lacked the durable defenses of stone fortresses. When Henry II came to power in 1154, one of his first acts was to order over 100 of them dismantled. Their speed had served short-term control, but their structural weakness and political illegitimacy left them abandoned, destroyed, or irrelevant within a generation. Another example came from the Crusader states. The castle of Bagras in northern Syria, taken over by the Knights Templar in the late 12th century, was heavily modified in record time to strengthen Christian control in the region. But poor foundations and rushed design led to structural instability. When Saladin's forces advanced in 1188, the castle fell within desert's walls, breached not just by siege weapons, but by years of water damage and flawed construction. Engineers had reinforced the visible defenses, but neglected the hillsides. Geology, the result was a fortress that looked imposing but failed under pressure. Even stone couldn't guarantee strength if laid too quickly. At Château de Saint-Maurice, in Savoy, records from the late 13th century describe collapses during construction due to inferior mortar and unseasoned timber. Efforts to speed the timeline led to long-term instability. Repairs were constant, and the castle's military use declined within decades. The cost of rushing wasn't always immediate. Some castles stood for years before their faults were exposed, crumbling under siege or falling into ruin from neglect. Others were left unfinished entirely, as political circumstances shifted faster than the walls could rise. Building fast was sometimes necessary. But when haste replaced planning, the result wasn't just wasted labor. It was exposure, military, political, and strategic. In a world where walls were meant to project power, a failed fortress signaled something far worse: weakness. Many of the castles built in haste, under the threat of war or rebellion, were not designed for permanence. Yet centuries later, their ruins still dominate the landscapes of Europe and the Near East. What they reveal is not just military strategy or architectural technique, but something deeper about the people who built them. At Conwy in North Wales, the grey stone walls still rise above the estuary, their towers intact, their battlements weathered but solid. Constructed in under 5 years, between 1283 and 1287, by order of Edward I. Conwy was part of a larger campaign to crush Welsh resistance. The labour was intense. Thousands of masons, carpenters, quarrymen, and labourers worked season after season in harsh conditions. The castle was built to secure a hostile population, not to survive a millennium. Yet it has. In France, the keep of Château de Vincennes still stands, 12 stories tall. Started in the 14th century under King Jean II. It was meant to guard royal authority during a period of political instability and foreign invasion. Its walls, rushed in construction during phases of conflict, were never meant to compete with modern artillery. Still, they remain a visible part of Parisian history. In the Levant, Crac des Chevaliers towers over the Syrian plains, expanded by the Knights Hospitaller during the 12th century. It was engineered with speed and urgency to protect vulnerable Crusader outposts. The stone corridors, once echoing with soldiers' footsteps, now remain mostly silent but intact, despite centuries of earthquakes, invasions, and abandonment. These castles show the reach of human coordination before industrialization. Without machines, they moved mountains of stone. Without electricity, they calculated sight lines, water flow, and firing arcs. Their builders had no modern materials, no reinforced steel, no powered cranes yet. They created structures that withstood not only war but time. More than relics, these castles are historical records. They reveal the anxieties of rulers, the conditions of laborers, the priorities of societies under pressure. They weren't built for eternity, but through them, the motivations of those who constructed them, the desperation, the fear, the authority, the vision are still visible. The walls have outlasted the wars they were built for. What remains is not just stone, but proof of what humans once did with almost nothing except urgency, knowledge, and relentless effort.